Hi, my name is James Kim. Uh, Beat Kim and I have built an application throughout this semester. Our application is about object tracking. I will demonstrate our application for this video. Okay, let's get started. So first of all, we're gonna open this framework IDE called Qt Framework. So what you see, the IDE called the Qt Framework. At first, we have tried this application with the PyQt. PyQt is using Qt framework with the Python, but there are some of the issues that can apply for this application. So we just changed our project application to using C++ rather using Python. This framework is really handy IDE than any other IDE, especially for GUI application. But you have to learn some of the features that Qt framework will provide. But when you get used to it, as long as you get used to it, Qt framework will reduce lots of times for the GUI application. Another main thing that we used for this application is OpenCV library. So OpenCV stands for the Open Source Computer Vision Library, which is the open source computer vision and machine learning software library. There are several versions and it works with several languages, but we used C++ for our project. This OpenCV library is a really popular in the computer vision area. So if you want to learn more, that will be really helpful. Alrighty, so let's get started demonstrating our application. So first of all, let's run the application. There are some of the features that you may see when it opens. So when it opens, there are a few functioning you may see. So also there are some different displaying sections and 3 different buttons. So playing button and capture model button, an open video and image button. This open video image button will prompt the path of the file to the application so that the application may receive the path of the file so that it can run it. In order for us to have more accurate application, we take the application with a multi-thread. When we use a single thread, it does not work. The application does not work with other functioning while the video clip is playing. But when we use the multi-thread, it can control dilate and erosion or other functionings while video clip is playing, which is really, it's supposed to be that way. So while we are playing the video clip, we can't do anything. That's what's the point for the application. So we use a multi-threaded. So first displaying section is for the video itself. While video is playing, this section will display normal video clip with a white rectangle frame and contour. I will talk about this in a later demonstration. And second displaying section here called foreground mask. When video is playing and there are some motional object that is detected from the base video up in here, foreground mask takes the shape of the outline of the object. So we call that shape of outline of the object as a contour. Contour is the outline of shape the object. From this contour, foreground mask will send this to the video clip up in here and make a white rectangle frame outside of the contour, which is outside of the object. And then, based on this white rectangle frame, an object detected section, which is located right up top right corner, will draw a black circle to track the object. We calculate all the features, such as distances and velocity, or even location, and so on. on the control section, which is located right bottom part of the application, will control the contour so that this application may be able to control more accurate object tracking and detection. So dilate will fill up the white color to the contour so that contour can be more smoother looking. And erosion will shrink the contour. Here, erosion will shrink the contour from the outside so that it can narrow it down. It can be more slender. Let me show you. Here's thing, here, open. So that as I told you, this section, this white rectangle and this white shape of the object will be drawn by here in foreground mask. And as you see, you can choose your dilation. So you can dilate that different filling up differently. So can you see that? And then there's another part called erosion. You can make it skinnier, right? And this white rectangle is kind of shaky, as you see, but this black circle is still very smoothly working. When we hit this issue, we had a concern that our accurate rate of object detection will be decreased. But there are some algorithm called a Kalman filter. Kalman filter will help the object, both prediction of the object and correct the object so that detected black circle, this one, will be more smoother. So even though the object is outside of the frame, it's still going to follow the detection, which is prediction, and it's still following the objection. Even though it's very shaky, this one is not that shakier than this one, as you see. I think this is about how we implement it. So thank you for listening, and thank you for watching the video. Bye-bye.